But I'm very pleased to introduce our first speaker today, whose name is Petr Knoth, and he is the Senior Research Fellow in Text and Data Mining at Open University in the UK, and also very well known in our community because he runs the core aggregator service that aggregates metadata and full text content from repositories and provides a discovery service. And Petr is going to talk about the hottest topic at the moment, which is machine learning and artificial intelligence in repositories. And last night when I was going through my notes and doing a little bit of research, I discovered that Costa Rica is the first Latin American country to sign the UNESCO Declaration on AI and ethical treatment of artificial intelligence. So it's appropriate that we're here today talking about this in Costa Rica. So with that, I'd like to welcome Petr to the floor.
Thank you, Kathleen, so much for the wonderful introduction. I'm really, really pleased to be here, very much honored to be here and be able to speak to you about this really, really hot topic, as Kathleen said. My talk is called Machine Learning and AI for and from Open Repositories, and it's because I see repositories as a huge opportunity for unlocking the power of open research and use it for basically the public good. Kathleen already said everything about me. I just want to mention one thing. The Confederation of Open Access Repositories core has a very similar name to the core that I run, which is an indexing system. And so the name core comes from the word connecting repositories, basically. So this is how we perhaps differ. It's not Confederation of Open Access Repositories, but connecting repositories. Before I start, I just want to tell you a little bit about my team. So I run a team called Big Scientific Data and Text Analytics Group. And the mission of our team is AI for open and responsible research. We run the core system, as it was mentioned. Core has at the moment about 20 million monthly active users. It aggregates and indexes about 34 million full text research papers and about 260 million metadata records. And I think what's particularly amazing about this is that this is not our content. This is the content that comes from the network. And then you can sort of see the power of the global network in having a huge pool of open research papers available in over 11,000 repository systems that we serve. We are signatories of the open scholarly infrastructures, of the principles of open scholarly infrastructures, and we really try to adhere to them as much as we can. Core delivers a range of services in areas of content discovery and raw data access. Raw data access is actually one of the key topics of today's talk, because that's about machine access to open repositories. If we don't have machine access to open repositories, we won't be able to have AI on top of repositories. So it's the foundations of the AI. My team also does research in several areas. All of it is related to the processing of scientific content. And so we do things in the areas of document classification, rapid systematic reviews, research graphs, and recommender systems for research. And I will be showing you some of these examples today. So the topic of my talk will be structured along three themes. The first one is about how can AI and machine learning applied to research papers benefit and transform research in general. The second part will be about how can open repositories enable this by providing machine access to the research content. What is it that repositories need to do in order to make all of this possible? And the final part of my talk will be about how can AI and machine learning be used actually for the benefit of the institutions running repositories? How can we utilize AI for research intelligence and for improving sort of repository workflows? So let me go to the first topic. And before I do so, I just want to mention that this is from, I think, a paper from the Confederation of Open Access Repositories about 10 years ago, basically. And this is really, you know, something that shows how much foresight there was within the Confederation of Open Access Repositories a long time ago. And now, when AI has really become powerful and it's been recognized how powerful it is, this is still current, basically, and doesn't need to be changed. No word needs to be changed here. So, okay, so how can AI transform research? Research literature sort of documents all the knowledge that we have assembled as human species. It's really interesting to look at research at the global body of scientific publications and compare it, for instance, to the largest encyclopedia in the world, Wikipedia. Would you believe that, would you think that it's bigger or smaller than Wikipedia, the body of research literature? Well, this is just a rhetorical question. Of course, it's significantly bigger. You know, it's a magnitude bigger, basically. So, you know, in Wikipedia, in an encyclopedia, you typically have just one specific opinion about one specific article about a given topic, because that's the definition of it. But in research, you can have lots of opinions, basically. You can have the scientific discussion. And effectively, as much as we have assembled as human species, we have documented within research papers. And now our mission is, the mission of all of us here, I suppose, is to make this open and make it reusable for the benefit of the society. Several years ago, I've been commonly questioned about why text and data, why for the purposes of text and data mining, I need access to everything that is available in the world. And I created this diagram, which basically talks about undefined sample use cases and a priori defined sample use cases. I'll make it a little bit simpler. Effectively, there is a limited number of use cases in text and data mining that can be satisfied with downloading, if you're accessing, you know, papers from a specific journal or a selection of journals, and then you do something on top of this content, and that sort of has a benefit. And I have, and these are sort of named in the diagram. So some examples of them you can see there. But there are many use cases, in fact, for which you really need access to basically everything. And unless we have access to completely all research papers in the world, these use cases cannot be actually fully satisfied. These include, for instance, plagiarism detection. How can you detect plagiates if you're not aware of everything that has ever been written, basically? How can you really build proper recommendation systems if you're not aware of all the papers that exist in their totality, basically? So the network of open repositories serves here a really important purpose. It should make everything that the humans have assembled available. And if something is missing, there is a really big cost to that, potentially, because some of these use cases will be affected by it. They will not be able to be utilized to their full potential. Now, I'm going to give 3 examples of where AI can help the society. It's just 3 of them, and I'm sure that you would be able to come up with many, many more of such use cases. The first one is about AI for systematic reviews. Systematic reviews are an important, a really important undertaking in several disciplines, including, let's say, world and climate change, sustainability, and also in medicine. Creating a systematic review usually takes a lot of time. Sometimes they take 2 years to be created, basically. They are very time consuming. As a result of that, we've been talking about AI, that can AI effectively be used to limit and reduce the time that is needed to create a systematic review. And we have therefore started talking about something called rapid reviews. There has also been a discussion in the scientific community about something called living reviews. Living reviews are effectively updates to existing systematic reviews, because it takes a lot of time to produce a review. The review sometimes becomes obsolete as soon as it becomes available. And that is a really huge problem. You know, how do we keep the reviews constantly updated with new findings? So living reviews and rapid reviews are important topics. So if you look, this chart shows, or this diagram sort of shows you the a table which lists all the stages of creating a systematic review. And I have highlighted stages 7 to 11, which are about screening abstracts, obtaining full text, screening full text, snowballing, and extracting data. These steps are used to sift through a lot of literature and then consider what is relevant for a specific systematic review. That is the stage that usually takes most of the time to people, to humans, basically. And this can be significantly reduced by AI. My team has been working in this space a little bit, and we've got some models built, basically, and some systems. This is an example where you see, for instance, for a specific review that 2,072 papers were selected in the first stage. Then after screening for abstracts, it's been found that basically many of them are actually not relevant to the study of the systematic review, and then only 2% in the end made it to the systematic review. This is an example of how such screening looks like. Typically, you would have something called inclusion criteria, which might basically be some sort of requirements on how large the cohort study needs to be. It needs to be whether it considers male or female, what are the intervention criteria, and so on. There are also something called exclusion criteria, which means that, for instance, that if the paper is about something that is for instance, the paper is not written in English, then maybe that is not something that you want to review in a specific context. The AI can be used here to basically sift through the literature and do something like this. We can provide basically an interface to the person who is conducting the systematic review and show them basically the papers and give them suggestions here as they are reviewing what inclusion or exclusion criteria have been met, make sort of predictions about this so that they can then make the final decisions. So this was just one example. Another example, but that example sort of illustrated how that one needs to consider the value of systematic reviews for the society. It has a really, really important value. For instance, on the basis of systematic reviews, political or policy actions are often determined. These actions could be about prescribing or not prescribing someone a specific drug. And so the impact of doing this and being able to do this over all the literature that exists in open repositories is pretty substantial. A second area, which I would like to mention, is about AI for citation typing and research assessment. Research assessment is these days a topic that is very controversial in the society in a lot of countries. In many countries, it's conducted on the basis of counting citations. In some countries, it's based on evaluating people based on the journal impact factor. What we know, I think, and what is sort of almost universally known, is that research assessment changes the way researchers behave, and it reduces the power of the research workforce, basically. So if we don't have an effective research assessment process, we might be promoting the wrong people, which effectively then leads to the research workforce not being the one that we would really like to have. I think that a very big problem is treating every citation in the same way. Every citation is different. It is a difference whether it should be semantically different, and it should make a difference whether I'm citing you just because I'm mentioning your work, or whether I'm citing you because I'm actually following on your work and I'm building on the previous approaches. AI can be used these days to build models that can do this for us and at the scale of all the research papers. And we've been in my team building some models that can predict the type of citation. Just to think a little bit about the impact of that, again, if we can change the research assessment system through providing some better indicators to the evaluators. We will provide better incentives to researchers. We will motivate them to write better papers, and we will motivate them to spend time in doing things that really matter. Not necessarily maybe publishing as many research papers as possible, but maybe delivering research papers which are made for other people to build on. The third topic I'd like to mention is very hot at the moment, and it's about GPT. In my team, we've built something, a machine learning system called Core GPT. And it's been built by combining the power of the well-known ChatGPT with the power of openly aggregated papers from repositories. What have we done, basically? We have taken the papers, and actually, before I go there, tell me a little bit of a joke about ChatGPT. The problem with ChatGPT is that the responses of ChatGPT are not really grounded in scientific literature. And ChatGPT can often invent things, basically, and make them to our liking. So unfortunately, ChatGPT doesn't really engage particularly well with scientific references. But if you ask it to provide content based on these scientific references, it's pretty good at inventing them, including inventing the DOIs for these imaginary papers. So what we have built is that effectively an adaptation of GPT based on data in Core, where you can ask a particular question. I would normally had a video for this, but I don't think the video is really important. So a question can be, for instance, what are the latest research trends in biomimicry? And Core GPT then comes up with text where basically the references which you can see in the text are specifically going to well-known scientific papers. This basically gives the reader the opportunity to check whether ChatGPT is just inventing things and check effectively the validity of the claims. So what's the difference between ChatGPT and Core GPT? So ChatGPT can get sometimes confused. It can mix things. It can basically be made to argue your way, producing effectively biased text. It can start inventing things. And what Core GPT does is that it answers the need, basically the response is grounded and it must be made from research papers which are available in open repositories. So it needs to be composed based on that text. This makes it easier for anyone who reads the text to assess the trustworthiness of the answer. What is the impact of this for the society? Well, the impact could be that ChatGPT, by all means, is a huge threat for the society. It can be used, for instance, to create really powerful bots on Twitter that massage the society with falsely claims about all sorts of areas, all sorts of aspects. And perhaps if we make research papers available and if we build AI models that are forced to effectively reply only based on evidence contained within open research literature, we have some means to fight this misinformation. I think this is important for the democracy. It's important for maintaining our way of life. Okay, the last example I want to show is called Core AI Expert Finder. We know that a lot of open access journals and effectively publishers these days struggle with finding reviewers for the work that is for new papers, basically. So an academic submits a paper, and typically the publisher looks for several reviewers, and very often most of them say that they don't have the time to review those papers, and this leads to effectively the publisher spending lots of time, and also the whole scholarly system being quite inefficient, basically. What if we could recommend the people who are experts in providing their expertise, basically, on a specific document automatically? But now think about something more. Think about the way how peer reviewers are in fact allocated by most journals. In many cases, peer reviewers are allocated because the editor knows them. Is that a good way of allocation, or is that in fact a biased allocation of peer reviewers? Does it lead to effectively a fairness in the process of accepting research literature for publication, or does it lead in fact to unfairness and making it difficult, for instance, for authors from the global south or from developing countries to actually get published? Because of course, peer review committees composed of academics from the Western world, let's say, are more likely to be accepting papers from the same kind of community. So effectively, the AI Expert Finder can also be used to create more balanced peer review committees. Typically, you have 3 peer reviewers, so maybe you can use AI to effectively ensure that the reviewers don't have conflicts of interest. And I think that's the key value of using AI for finding peer reviewers, reducing the bias in the peer review panels. Okay, now I'd like to talk for a little short while about the crucial role of repositories in providing machine access to research content. I gave you 4 examples of how AI can be really used to improve the way how research is conducted. But if repositories don't provide machine access to the content, this cannot be realized. I have 2 principles and then I have a few recommendations. The key principle for me is that repositories should always establish a link from the metadata record, the item, from the record to the item that the metadata record describes. It's quite ironic, but very often we find in repositories basically some sort of Dublin core metadata records which describe a particular object. But for a machine to identify which and link that metadata record with the object itself is actually often not trivial. And there are often multiple possibilities and it leads to errors. So doing this in an unambiguous way is, I think, really very, very important. Sorry. The second principle is that repositories should provide universal access to machines with the same level of access as humans have. What we, and I will illustrate this on actually this example first. There's a convention which is used on the web, which is called robots text. And unfortunately, we still see that some repositories block access to robots, or they block access to some of the robots. Robots are machines which go to the repository to access and index and do something interesting with the content. Repositories might have very good reasons for doing this kind of stuff. And this is an example from one specific repository which basically blocks, which gives access to Yahoo and Googlebot for all the content in the repository, but doesn't give access to anyone else. I think this is a bad example of use of this. Then this repository is effectively open to Google and to Yahoo, but not to anyone else. I think this is exactly what we don't want to be seeing in open repositories. We want, I think it would be okay for a repository to perhaps block perpetrators and those who misuse the repository in a way that basically brings their systems down and so on. But so I think blacklisting is okay, but sort of blacklisting everyone by default, unless you are a powerful Google or Yahoo, is, I think, not the right approach. Yahoo no longer really is relevant here, but Google definitely is, and others. Okay, sorry. Another thing which I feel is very important is that some repositories really care about describing their metadata in a really nice way, and that's a good thing. But fail to test that their OAI-PMH endpoint, which effectively exposes all the metadata, is operational. I would really, in this case, recommend that all institutions check and monitor that their OAI-PMH endpoints remain to be operational. And it can be done. For instance, Core provides the Core repository dashboard, which is a free tool which allows any repository manager to go and see when their repository was last harvested, how much content we managed to harvest from them, so they can check what is the outside view of their organization. I realized multiple times, actually many times, that when people use it, they often come to us and they say, I believe that in my repository there was 60,000 metadata records, but you are only showing 55,000. And that led further down the line to some changes in the way that the repository exposes the metadata. So effectively, by having this sort of I think if you are providing a website, you don't only program the website, you also want to go and to the computer of your friend, maybe, and see how does my website look from that computer. And I think that's precisely about this. It's not, we should not only provide repositories, but we should make sure that the repositories are working properly, and we need to keep watching it all the time. Okay, validation of metadata. So I think it's critically important that repositories adopt some application profile which extends the basic Dublin core, which has become pretty much a standard, I think, in repositories, although not implemented in a completely standard way. There are multiple application profiles here. I happen to be associated with one of them, together with Paul, who is here and who has led RIOX. I would recommend institutions to adopt, for instance, RIOX, but if they don't like it, they can adopt any other application profiles. But what is critically important to me is that, and I think should be to everyone, is that repositories don't only adopt the metadata profile, that they also use a validator to check that they have done this correctly. Because unless you do it, you won't achieve interoperability. And so in this case, Core is at the moment implementing and has implemented a validator for RIOX, which institutions can use to validate that they have done so properly. Another important aspect for me is supporting signposting. Signposting, the adoption of signposting within repositories is something which is not particularly implementation heavy. It basically means that, and it helps machines to navigate repositories in order to locate the content and distinguish the content from the landing page. Effectively, in the metadata, we often find identifiers which, when clicked on, dereference us or lead us to the landing page. And so the question is then, how do I find from the landing page the exact item? How do I find the manuscript? This is trivial for a human, but it's not necessarily trivial for a machine. So by using signposting, signposting allows you to use HTTP headers to tell the machine where it finds the manuscript. Okay, and finally, I want to say that there is a lot more happening in this space. I mentioned only some of the really basic things that, in my opinion, every single repository should deal with. But the Confederation of Open Access Repositories Next Generation Repositories Working Group has created some behaviors and technical recommendations which are still being sort of discussed and worked upon. And I would encourage everyone to sort of get in touch with us and work with us, because I think there is not enough people, I think, in this space, personally. Okay, so let's, sorry, I made a slight mistake here in this presentation. So I just want to mix the slide here. So, these are some of the behaviors that we've been talking about in this Next Generation Repositories Working Group. So things for managing and providing access to a wide diversity of resources. These are some of the principles that these behaviors should have. The repositories should be resource-centric, repositories should be machine-friendly. I mean, this is effectively what I've been talking about so far, so I'll come back just to this. Okay, the very last part of my talk is about AI and machine learning for research intelligence and for improving repository workflows. And again, I'm going to give a few examples, and if Kathleen says that I need to stop, then I will reduce that number. But I want to give you some examples of why I think doing something within an indexing system might be particularly worthwhile for repositories. So, for instance, these days, many metadata records, the vast majority of metadata records in repositories and also in Crossref from publishers don't have affiliation information. So you don't know who wrote, which organizations, which research performing organizations are behind this paper. We don't know that. If I want to see something called the publication footprint for an institution, this becomes really difficult. And I realize that this is something which is very important for especially US institutions. So if I'm, let's say, Stanford University, and I would like to see where are the papers that my academics made available located, then this is not a trivial problem. What we're doing at CORE at the moment is that we are using several signals, both from the full text of the paper, as well as from other external sources, to find the affiliations for a given paper. We parse the text, we extract, for instance, email addresses, and based on the suffix of the email address, it's typically quite possible to map the suffix of the email address to the organization where the academic is from. That's one signal, but there are other signals. For instance, we can obviously parse the string, which says, for instance, National Institute of Informatics, and then map it to the specific organization. What will become really powerful is that a lot of you will be aware of the ROR, the Registry of Open of Research Organizations, basically, and we will be trying to map these affiliations that we extract to the ROR IDs. This will be incredibly powerful for a range of use cases, which include, for instance, managing open access compliance and helping people to recognize that, for instance, they need to deposit into a repository within a specific time. It can also be particularly important when, for instance, a research paper becomes available somewhere, for instance, on a publisher's platform, and we want to automatically deposit it into a repository. Or we have something in a repository, and which is, let's say, in a repository of a funding institution, and we want to automatically deposit it also to the repository of the institution it belongs to. So we can automate these processes if we have affiliation extraction. Another important aspect which we need to deal with, and we need to deal with urgently, is deduplication. Due to open access mandates, which are becoming more and more prevalent in a lot of countries, and they are a good thing, we have sometimes the requirement, we see often the requirement that academics need to deposit content into an institutional repository within a certain period of time after publication. And typically all academics, even if they collaborate on a paper, and the paper might be a collaboration of, let's say, 3 or 5 institutions, the paper would be expected to end up in the repositories of all of those institutions. Not in every country, but in some countries certainly, yes. For instance, in the UK, that's the norm. This means that the same paper ends up in multiple places, with all the implications of it. For instance, we might mint 5 different DOIs for the same paper. But as a result of that, it's really important for us to be able to deduplicate papers. And deduplication of papers in repositories is a bit challenging. If you think about how deduplication is done, for instance, on web pages, it typically uses a method called locality sensitive hashing, often called SIMHash, and there are some other examples of it. But the challenge in repositories is that we need to sometimes deduplicate a metadata record against a full text document, or a metadata record against another metadata record, or a metadata record or 2 full texts. For instance, 2 full texts are basically easy, but metadata is also easy, but metadata against full text or full text against metadata is often a challenge. So what we have done in my team is that we've done basically a model for deduplication, which is at the moment operational within the core infrastructure. You can use it also to, you will be able to see the results of this model for your own repository in the core repository dashboard. This will be something we will be announcing this year. Effectively, you will be able to see that the duplicate content in your own repository, which is also common, and by duplicate content, I also mean, or near duplicate content, I mean also different versions of the same manuscript, which are natural, which are not necessarily wrong. It's just that basically we sometimes have a preprint, then we have an article accepted manuscript, then we have a version of record. So all of these are something that we need to consider. Our system, obviously, this is an AI system, so it reaches about 90% performance. The use of it is also that when you go to core search and you find a particular paper, you might see that that paper is available from multiple locations. It also can be used to, we will try to enable the use that for the publication footprint idea. So effectively, if you want to find all papers which belong to your institution, show me where they are located. And as a repository manager, you will be able to download the report and see where these papers are and what their metadata are. Okay, so another use is data enrichment. When academics deposit content into repositories, very often they might make mistakes in the deposit process. And sometimes they are also missing information that would be desirable for them to have at the time of the deposit. For instance, sometimes academics deposit into repositories before the exact time of the publication, at which point they, for instance, don't know the DOI. It would be absolutely wonderful, right, if the repository could later, at a later stage, absorb the DOI and enrich its metadata record. Yes, perfect. So what we are providing is effectively exactly that kind of a system, that we search on behalf of the repository for the DOIs in other systems. And if we manage to find it, we make it available through the core repository dashboard to the repository manager. They can then download it as a CSV, and they can, for instance, use it to enrich their metadata records. This can be done also for ORCID IDs and for all sorts of other areas. I'll mention, this will be the last thing I will mention. It's about document classification. It is really, really interesting, but document classification in a distributed environment really doesn't work, basically. So if we ask people to tag using some sort of a classification, which topic their paper belongs to, then they do it pretty badly. Because these are different people, they come from different backgrounds, and so forth. It's typically a mess. With my team, we have used the data from the UK Research Excellence Framework, about 150,000 papers, which were tagged manually and very carefully into 36 categories. And we have used this to train a machine learning model. And we have done this actually as an open competition. So I participate and co-organize something called the Scholarly Document Processing workshop together with many other people. And we had a challenge there, effectively a competition, where anyone could come and they could build a system for classification of scientific documents, basically. And so we've got one winner from this competition, basically, which we are now trying to make available within core. This will mean that within the core API, we will be able to tell anyone the category, the subject class, basically, a specific paper belongs to. And it doesn't require the repository to make any of that tagging itself, basically. It doesn't require the academic to do anything. The accuracy with this is actually relatively high. So, okay, so what I want to say is basically that core is funded from something called the membership scheme. We are based on basically we exist on the goodwill of the people who are willing to become part of and become our members. If people decide to become our members, then they also can be represented on the board of supporters of core. We have 3 levels of membership. One is starting, that is completely free, and I would really encourage everyone to at least, who runs a repository, to at least register for that version, because it gives you access to the core repository dashboard and some of the features that I've been talking about. And if someone wants the representation within the core board of supporters, then they are encouraged, of course, to join also the supporting and sustaining membership. Or if they require something, some extra services, then they are, of course, more than welcome. The reason I'm saying this is that we can also help you to make sure that your repository is machine friendly And we run something called the core repository health check service. For those who are our sustaining members, we effectively conduct an investigation of a specific repository system, at which point we recommend the actions that the repository should take in order to improve machine access to the content. So that's all that I wanted to say. There are some references. So a lot of these things that I've been talking about are based on scientific papers which my group has published, and you can find them here in the presentation, which will also be made public. This is my last slide. In my view, machine learning and AI has really the potential to transform all stages of the research process, including really how we access the knowledge, how we consume the knowledge, how we act on the knowledge. Open repositories are critical in making that possible. Without open repositories, we will be, as a society, much more susceptible to misinformation and misuse of AI than if basically open content is made available and easily accessible to machines. And already at this point in time, AI and machine learning, in fact, provide opportunities to us. We can deliver and run repositories in a better way, have higher quality metadata if we embrace AI. That's my message. Thank you so much.